Let me tell you mine. Secondary inakimbisha watu sana. But now it's
Really?
done.
Yeah, now
So
it's
now
done.
I'm back to watoto wameenda shule, so back to
Okay.
full swing. Yeah.
Okay, no problem. You're just in time, Basi, because today we're starting another topic, so you will not feel lost.
Yeah, I saw on the chat.
Yeah. Okay. Daniel, how are you?
I'm fine, thank you. How are you?
Tami niko poa.
Nice.
What were you supposed to talk about? Unafaa kuongelelea pure functions.
Pure functions.
Okay. Let me just share my screen and then we start. We'll walk through those terminologies pole. So you guys will tell me when you can see my screen. My screen is visible.
Yeah.
Okay. I had started writing some notes here. We're just doing it. So Fatma was supposed to do the presenting, but she's not feeling well, so she will not be able to attend. So let me just open this file. So this is just an empty HTML, just an empty HTML file haina kitu. Then I just have these 3 console logs. I will put them side by side. This is too big. Okay. So I think we can just start with scopes. So in JavaScript, we have 3 scopes. We have global scope, we have block scope, and we have function scope. So anytime you write your variable, so if you declare a variable, if you write a function, that is not inside of another function or is not inside of a block of code, that thing is referred to as being in the global scope. So for example, let's go into our code. So if I come here, move all this, then if I declare a variable here, let's global equal to I am global. So this variable is in the global scope. So it's accessible to anything, like a function can have access to it. Let's just try that. So if we have a function get global, and then we console log global, and see we have access to it. If I come and check, I should see. Okay, I haven't called it, so I need to call get global. See, I'm global. So we have access to this because it's declared in the global scope. So anything that is not within a function or a block, and I'll show you what a block means, is in the global scope. So this is accessible to anything in the program. Now, if you were to declare a variable here, this variable that we have here is only accessible within this scope, this function scope. So we have, the first thing we have is we have global scope, And then we have function scope. So anything that is within this function is only available near this function, this scope. Basically, from here up to here, line 8. If you try to console log this in the global scope, you will not find it. You can see function scope is not defined. So it's not available. You can't see it because it's in this scope, so we cannot be able to see it. But we can see the global. So anything that you declare within a function is scoped to that function. So that's function scope. And then we have another one called the block scope. So a block is simply a pair of curly braces. If I declare a variable here, let's scoped equal to block scoped. And then I console log this. And see, I am block scope. So we have the global here. We also have this block scope that is scoped within these two curly braces. But if I try to access it outside of this block, if I do this block scoped, I will get a reference error. It can't find the block scoped because it's only within these two curly braces. It's not visible to anything else. Now let's did you see what happened? You see, I do have like a block here. When I use let, right? When I use let, so this is a perfect example of let and const being block scoped. It's only visible within this block of code. Right? But var is not block scoped. What happens is, right, when you have var, what happens? It gets put on the global scope. So it will simply take this and put it in the global scope. But when you do the same thing using let, it's only available within these two blocks. What if we go back to var and then I take this, then I put it here. Okay, so let me remove this. Remove this for now. Then I will also comment this out. So we are getting undefined. Can anyone tell me why we are getting undefined? Does anyone have an idea why we are getting undefined in the console? So we are not getting a reference error, but we are getting undefined. It has something to do with a topic we covered, I think last week or the other week before that. I think it was last week. Last week, I'm not sure. Can anyone try to figure out why we're getting undefined? Because we are trying to log this block scope, but we're getting undefined.
Is it because of how the tasks are running and how they're being queued?
Okay, good attempt. So it has something to do with that. Try. Other than that, what else did we look at? Because what this means is, so it is finding a variable called block scoped. It just doesn't have anything there. So we do have the variable block scoped in memory, but it's blank. What did we conclude when we were looking at? There was another topic. Well, actually, it's not last week. It's the week before that.
Is it hoisting?
Yes, it's hoisting. Exactly. When we talked about hoisting, we said when you have variables, when you're hoisting variables, yes, they are hoisted to the top of the context, your current context, but they're not initialized. So we have the variable, yes, but the value is not there because we have not yet initialized it. When you put it below, when you move it down here now, it's working because we've already given it a value. So let and const are block scoped. So anytime you hear that term, now you know why they call it block scoped. You've seen when we put let instead of var, it doesn't go above, it doesn't go to the global scope. It remains within that block. So you can see when you use let, you're not getting undefined, you're getting a reference error. So it means that thing is not even in, it hasn't been hoisted. Haiko, basically it's not in memory. We don't have a reference to it. Hence the name reference error. Block scoped is not defined. Okay, let's do something else interesting just to, so let me remove that and then I will take this piece of code, then I will bring it here. And this is the global, so nitatoa hii for now. Then I will console log block scoped, and then I will call global. Okay. So we are getting block scoped from this right here because we are calling the function. What if we try to instead, let's take this, put it here. Again, reference error. So nothing new there because we know let is block scoped. So it's only going to be available within these two, right? And then if I come here and I instead use var undefined, so fine, same behavior, right? Same behavior. We know that block scoped is being hoisted, right? So this is the behavior we expect. What if we console log block scoped? I will remove this. Now, look at that. Now, our block scope is now not available at all. But when we do it here, kifanya hapa ndani, we have undefined. But when you do it in the global scope, you're getting a reference error. So two different errors. So can anyone tell me why when we put what's going on? Because if it's being hoisted, right? Being hoisted, for sure, right here you can see it's being hoisted. That's why we have undefined. But when you put it outside of, like in the global scope, and you try to log that value, we are not getting it. It's not there. So can anyone try to figure out what is going on? Anyone? Does anyone have an idea?
Can I just maybe?
Go ahead, Albert.
There's a session that we were talking about the execution phase and the, what was the other one? The first one, the initial stage.
The global execution context.
Creation.
Creation and the execution phase.
Yeah.
So during the creation for the global scope, so the scope is actually created first, and this function scope, it's not created. So everything inside the function is like it is ignored. Now, when you call that function, then everything inside that function now goes into the creation stage. Now, hosting in our during the creation, not the the creation stage, and then you can now access it inside that function. If you try to accessing it outside the function, it has not been created, meaning it has not even been hosted yet.
Yes, good. That is why You cannot see it. So it has something to do with the creation phase and the execution phase. But what about the hoisting? So when I put it here, you can clearly see hoisting is happening, because there's normally confusion in terms of people think that the hoisting is like it literally takes your code and puts it hapa juu. But when you're inside a function, it's still being hoisted, but to the top of its scope. Kwa sababu, you see here, when we have the function and then we have the blocks, right? The var is being hoisted, but it's being hoisted to its current scope. So bado itapelekwa juu, yes, but not here, not in the global, within the function. It's going to be hoisted paka to the top of its scope. And its current scope is the get global function. So that's why we cannot see it huku nje, because it's not being hoisted outside of the function. It's being hoisted within the function. Is it making sense? Why when we console log within the function, we are getting undefined? But when we do it outside, we are not getting a reference error, meaning the thing is not even there, but hoisting is still occurring. So it's not that hoisting is not occurring, because that's a tricky question, because someone will ask you, is var being hoisted? And if you say no, that's wrong. It is being hoisted, but it's being hoisted up to this scope right here. That's why it's undefined.
So my explanation that hoisting occurs on the creation stage or during creation, was it correct, Ama?
It's still correct, because it's still being hoisted. It's still being hoisted, but now during the creation
of the function.
of the function, exactly.
Yeah.
Yes. Very good. Yeah. I see you're getting it. So that's why we are seeing undefined when we do it within the function, but when you do it outside of the function, you're getting a reference error. Okay. Any question up to that point? So I hope let and const are clear. I hope, like, when you when you hear someone saying that let and const are block scoped, I've shown you what it means. It simply means if you declare your variable as a let within a block like this, curly braces, it will not be hoisted. I tender anywhere past that point. It's not going to go above that block. It's just going to stay there. That's why when you use let, there's a difference. When you use let, you get a reference error here. If you use let here, you will not get undefined. You will get a reference error, because that thing it's not there. And see, it's not there at all. Same with const. They do the same thing. Right.
So I have a question here. So like this block scope, is it like functions and objects, or what is it? I've never seen something like a block alone like this.
The block.
Is it like something? Yeah, the block. Is it that like something that has an opening and closing curly brace, like functions and objects?
Yes, it's literally if you just have two curly braces in JavaScript, that's a block. You see it everywhere. So when you have an if statement, you normally have when you have an if statement, for example, if you have an if like that, and then that, this thing here is a block. So you can mimic that behavior even without having the if, because we know that this makes up a block. This. So it's not like you'll find yourself wanting to do this a lot, Maramingi. I just wanted to show you that a block is simply a pair of curly braces. A block that represents a block. So now if you declare anything up on Dani using let, it's only going to be available within that block, that space.
Got it. Yeah.
So that's fine. Let's see. So we have looked at scope. So basically, scope means, right? So this was created in the global scope. So anything that is within our code will have access to this variable, right? And then anything that we declare within our function is only visible within our function, not outside of the function. Haiwezi kupatikana huku nje. If you try to console log anything that was declared within a function, you will not find it. Now, there's something called a scope chain. So let me show you what I mean. So there is a certain game called, does anyone know, has anyone ever seen those Russian dolls in movies, whereby when you remove one, kuna kwanga nyingine ndani, a smaller one. When you remove that one, there's another smaller one ndani ya hiyo. Has anyone seen that? I think it's called Matryoshka or something.
Matryoshka, something.
Name?
Matryoshka.
Matryoshka.
Yeah.
You know the spelling? Let me just write Russian doll. The name of that game. Matryoshka. Matryoshka. But basically, you know what I mean. I've done some research into it. It's this thing, this one. So when you pull out the first doll, there's normally a smaller doll ndani yake. And then if you pull that doll also, there's another smaller one ndani yake, and so forth until you have a very small doll at the end of the game. So I want to use that to explain the scope chain because they are very similar. Like if you want to think about it at a high level, you can think about it that way. So we want to talk about now the scope chain. We've seen what scope is, right? We've seen what it is right here. So before I even go to that code, I'm going to do something here. So I'm going to ask you guys to tell me what is going to be response. If I have another function here, right, like that. I have another function within this function. Now, if I come here and I say console log, if I try to log this value, will I see it? This one. If I try to log function scoped, will I be able to see it here within this other function?
Yeah.
Mm-hmm.
You should. I think so.
Okay, let's try. Function scoped. Now, we need to be able to see it somehow because right now we'll not see anything because this is another function within this main function, the get global. And the get global is not returning anything. So for us to see whether we are actually getting this value, we have to return this function. Right? We have to return that function. Now, if I come here and I console log get global, so get global is the main function, it's the first function. I take this and I console log that. You can see I am getting back a function called scoped right here that has a console log. So because we know get global is a function, then what that means is if I want to see that, I know this is a function, it's returning a function. So if I want to see that, I can simply call it again. Now I can see scoped in the function because now we are calling this function. We are returning it, but I now want to invoke it. So I'm getting function scoped in the function. So we do have access to this scope. So if I put in another one here, so this is scoped, the first one. What if I come here and I have another one? I have another return. So our scoped is returning another one, another, I forgot to write function. So our scoped, this one is returning another function also. Let's write another variable here. Question. Our function here, does it have access to this one? Our function here, does it have access to this function, to this variable? Anyone? If I come in here and say console log scoped inner, what is going to be the value? I say scoped inner. Is it going to be undefined? Is it going to be a reference error? What are we going to get?
It will be accessible.
So we should be able to see it.
Yeah.
Okay. So now, right, to be able to now access this one now, so you can see we are still getting scoped in the function. So this is coming from this scoped first, this one, because we haven't changed the implementation here. If you want to now see this one, simply call it again. So now we have scoped. So this one is giving us this value. And then this scoped 2 is giving us this value scoped in. So we are creating a scope chain. So basically what it means is our function here, this function has access to the parent scope, which is this. And then our most inner function has access to, first of all, its own scope, which is here. And then it also has access to the parent scope, which is here. And then it also has access to this other scope, the main scope, the get global. So it's going up twice. So here and then here. So this is what we call a scope chain. Because we can access, this inner one can access this scope, and it can also access this scope. So let's do that example. We'll revisit this size too, don't worry. Just want us to have a more practical example. So I will comment out this because I'd already written out the code. And then I will control KU. Then I will make this bigger. And then what I'm going to do, I will just comment out this entire line. Where's my last function? Okay, so let's go through the code. This is just a normal function. The game is called Matryoshka. That's the name of the game. That one for the Russian dolls. And then within this parent Matryoshka, this function, we are declaring a parent matrosh, which is this emoji of that character lady. And then we're simply console logging parent matrosh. That's all we are doing. And then at the bottom, we are simply calling parent Matryoshka. So if you check the console, you can see we're just getting 1. Right there. So now, I'll just comment out this one. Moja peke yake. Need so I have our parent Matryoshka is returning another function called child Matryoshka. Okay, now our child Matryoshka, this other function that is being returned by the parent, it also declares its own variable called child matrosh. And then we are simply adding the parent matrosh, which is this one, because remember we have access. Because we have access to the parent scope. So we can simply take this parent matrosh and add it, just give it one more emoji. So can anyone tell me what is going to be logged if we call this other function? Because currently in our execution, you're just calling the first one. If you want to call now the child matrosh, you simply add parentheses hapo. So what will be logged in the console? How many emojis? Take your time, look at the code. Has anyone figured it out? Or anyone who thinks they know what's going to be logged? How many emojis will we get? How many Russian doll emojis will we get this time? Go ahead. Who wants to answer? Am I in the chat? Let me check. Two. Nelson says two. Who else wants to? Three. Wekesa says three. Okay. Mary also says three. Okay, so we have two saying three, and Nelson is saying two. Okay, three, two. Mambo says two also. Anyone else want to?
Can I?
Yes, go ahead.
I think we'll have the first Matryoshka from the main what do you call it? The main function. So the parent Matryoshka, it will log out only one Matryoshka, and then the child, this first child, will log out two Matryoshkas. It will have the first the parent's Matryoshka and its own Matryoshka. So it will create something like a tree. So we have the first log having one, and then the second log having two.
Okay. All right. So in total, it's so all of you are correct, because in total you're going to get three, but the child Matryoshka will log two, and then the first parent will log one. So we'll have the first console log will be one, and then the second one will be two. So if we come here and we now call that second function, right, that is being returned by the parent Matryoshka, now gets two. So you can see why I was saying it looks very similar to that game, because now every child, so the smallest, for example, in that game, the smallest doll that you can have knows about every other doll before it, but not vice versa. The biggest doll doesn't know about everybody else beneath it, but the smallest one knows everything about everything before it. So everything that is the parent. So inajua kuhusu the immediate parent, it also knows about the grandparent, it also knows about the ancestor, and so forth and so forth. But it doesn't go backwards the same way. So the parent doesn't know everything about the children, because the scope chain goes up from your most inner function to your most outer. So in Enda, it's bubbling outwards. Make sense? Anybody with a question? Anyone with a question? So now this should make sense if I comment this out, and then I come down here and I simply add the braces for that. So now we have the parent Matryoshka, we have the child Matryoshka, and then we have the grandchild Matrosh. So now the functionality for this again changes. We are declaring a variable called grandchild Matryosh and setting that to child Matryosh, which is this plus one emoji. So remember, our child Matryosh has two dolls. If we add one more doll to it, we'll now have three for the grandchild. And if we check, if we now do that, you can see we now have the first one is logging just one, the second one is logging two, and then the grandchild is logging three. Is anyone lost? We We do a recap. Kuna mtu amepotea? Is there something that is not making sense? So I think now this is like a good visualization. So now, if you now take the last one, I have an extra curly braces somewhere.
The two that you introduced. Yeah.
Yeah. So now this should make sense. If we now call the last one the great grandchild, we now call it here, you should now see all of them. But why does that last one look off? You can see why. You can see why it's off by how many? 2 or 1. It's because of this. So here, what we do need to do, we need to get the grandchild matryosh and add 1. Take this. There we go. So you see our most inner function, the one that is at the bottom, knows about everybody else above it. So we can console log grandchild matryosh, we can console log child matryosh, and we can console log parent matryosh from the innermost function. That's the scope chain. We have access to everybody that is above us, but it doesn't go the same way downwards. It only goes upwards. Anyone with a question or something we need to redo, or does anyone feel like they want to explain it in a different way?
Ian, so practically, how can you use this in a like real world scenario, maybe in an app or something?
So scoping is used to make your logic private, because if you don't want like a program to access a particular variable like this one, I think I'll show you an example with I think you'll be able to see it with React, but I will show you, like even last week, what we were doing with functions and call stack. We already tulifanya kitu kama hii already. But to actually show you a practical example right now it's difficult at the top of my head to think of anything. I just know if you want to hide some functionality from from your outer scope or from your global scope, or you just want to hide some functionality, you just scope it within a function. So in an abstract way, some functionality, but I'll show you an example like once we get into like React, or even yeah. But the idea is just know that that thing exists, your scope. So if you see some weird behavior in your code, try to see whether if you're trying to access something and you're getting undefined or you're getting reference error, make sure you are understanding the scope. Anyone with a question? Is it a bit more clear, scopes? Anyone with a query? Okay. So if you guys are okay, then I think we can continue. Kama kuna mtu akona swali. Okay. Let's just comment that out for now. So now we want to talk about closures. I'm trying to think of an example how I will show you closure. Let's see. So if we have const function, use normal functions for now. Function func, and then we have let num is equal to true, and then we have let's see. Simply pass this number. Let's just put it here, and then let's return function takes in a value. Number is so confused, and then I want to return number is so I simply have a function called, let me remove this capital D, doubler. And within doubler, I simply have a variable called num. And then I'm returning another function. So this is syntax we've seen before. So I'm simply returning another function that takes in a number and then returns number times num. Okay, so now let's come down here. I now want to say const doubler double is equal to doubler, and then const double n is equal to double let me first write the code and then I will walk through it. So I first of all have a const double, and I'm setting that value equals to doubler. We know doubler, we know this doubler, this function is returning this function here, huyu hapa. If I console log, so I'll do this. If I console log, okay, see, if I console log double, and see, we are returning the function, this one here, this function right here, right? So it should make sense when I say, if I do double and I invoke it, it should make sense because we can see it's a function that is expecting a number, right? It's this inner function that is expecting a number. Then I simply have double 10. So I pass in 10 as an argument to this right here as a parameter. So if I come here and I say 10, what it's going to do is it's going to put this 10 here, then pass it down to here as the value, then multiply it by num. Now, this num, where is this num coming from? This num is coming from this doubler, the parent function. And we set that number to 2, right? And because we have looked at scopes, we know that our inner function has access to doubler, right? So that should make sense. Why it's taking 10, the number that we pass down, then multiplying it by 2. Because if you console log this, get 20. If I remove this, because it's taking this number and multiplying it by num, and num was defined here. Now the tricky bit is we already executed doubler, because this function, if you remember the call stack, right? Remember what we said about the call stack. We've already executed this and removed it from the call stack. We've popped it off. So this function no longer exists in memory. Ishatolewa. But somehow, right, our num still has access to number 2. So how is it doing that? How are we able to get number 2, even though the doubler function, the main parent function, has already been executed? It's already been removed from the call stack. But somehow we are still getting access to 2. That is where closure comes in. Because what happens, there's something we didn't talk about in terms of something called the heap, the memory heap. What's going to happen is that number, because it can see we have a closure, that number, this number 2, will be put in a separate place. Haitawekwa kwa call stack, because the call stack is in short term. It's going to be put in the heap, because we can see it knows that we are going to need to use that value again when we call function. Because now this function that we're returning is a completely separate thing. So if we now come here and say const double n, and then you set it equal to this variable double here. And this variable double is equal to doubler. And we know when we invoke doubler, it's returning a function. So this is a function, right? And you can see when I highlight, you can see it's telling me it's a function. So I can say double 10 is equal to, then I call double. And I give it 10. If I wanted to double a different, to triple, for example, triple, still double, because the variable is the same. Double 5. If you now say double, and then you now put 5. If you want to double another value, double 4, that is equal to double and 4. So if I console log all these values, 5, double 10, double 4. You see we are getting 10 for 5. So when you pass in 5, it's taking 5 times 2. When you double 10, it's taking 10 times 2. When you double 4, it takes 4 times 2, because this num is still available, because we were able to close over our scope. So this is closure. We already used our doubler here. It's already been used already, the parent function. We already executed it, but we still have access to this variable that was created, kappa. We still have access to it. Any questions? I know closures can be sometimes it's difficult.
I have a question.
Mm-hmm.
I think I have questions. The first one, this inner function, the one that we are returning, is the one that we passed the parameter number. So I expected that maybe we should have passed it to the parent function. So like, how is it accessing it? Directly from the calling of the function.
How is it accessing which one? Which one exactly?
You see line number 47.
Number 47.
Yeah, we have that parameter number. Yeah, I expected that we should pass it on line 45 on the doubler. then now the return function can access it from that function double. So it's accessing directly from the calling of the function there, number 53 or number 54, like that.
Number 54. Because so doubler, the parent function doubler is not taking in anything. It should put any argument. That's why when you call it the first time here, right? This is the parent function we are calling here without anything, right? And we are setting that value equal to double. Let me do this for a minute. We're setting that value. So hii yenye tuko hapa ya kwanza is the parent function, ni huyu. And based off of our implementation, right? This inner function that is being returned is the one that will take in a value, an input. So doubler is what we are calling here. But we know doubler returns a function. That's why when you do a console log, giving you this function that is being returned. So this double right now is a function. And what function is it? It's the function that is being returned by doubler. And now we know this function that we have here is what needs an input because it's the function that is being returned. Here juu haihitaji anything, it doesn't need anything. But the inner one has access. It now needs a value for us to be able to double the number.
So line 53 has to be there so that the others can work from 55.
Yes, it has to be there. You have to initiate that
doubler. Now I see. I thought like so you can't work without it. The line 53.
You can't. You need it to come first.
Okay.
It has to come first because it's the one that's going to create the scope that is now going to be closed over.
Okay. All right. Yeah, that's okay.
It makes sense. Because you see, you can't have access to this function without calling the doubler. Sindio, you have no way of getting it.
Yeah, sure.
Because it's scoped within the doubler. So the only way to find it is you first of all have to initialize the doubler. So the doubler has to be there. Makes sense.
Also, the closure. Can it be any other function, or it has to be anonymous?
Right here.
Yeah. The closure, can it be like named?
You see, doesn't matter whether you call it something or not. It will still work because you'll still be calling the same function. So whether you give it a name or not doesn't matter because it will still return it. So it doesn't have to be an anonymous function.
Okay, thank you.
Okay. Someone has a question in the chat. Okay, Catherine, I can see your hand is up.
Yeah, I have a question. In the function, do we have to return another function, or can we just pass in the parameters at the beginning?
Okay, so guide me, like where do you want us to pass in the...
With the doubler function.
So here in the doubler.
Yeah.
What do you want us to pass here?
We pass in the parameters, which now will call in our return statement. So
what do you pass in? What do we pass into that function?
We pass in num.
Pass in num?
Or number, yeah.
And then?
And then now it's a bit confusing.
I think maybe you can try passing number, then maybe don't pass it in the returned function.
Yeah.
See if it can.
I don't pass it in where? Yeah.
Yeah. You like don't pass number there, pass it on line 45.
Yeah.
But that seems far-fetched. How maybe that not a number.
Then
Yeah, that gives not a number. I'll pass the
why is it giving not a
yeah.
number?
Like
Where do I
yeah,
pass
I
it?
just wanted to see if that could work. Or what it would give.
Oh, but keep going. I think. What are you trying to do with let's see, we are highlighting number.
If we put the function like that,
then
it means we have to pass the parameter on line 53 instead of line 54. That will give an answer. Because we have changed the position of the parameter from the function doubler to the from our return function to the function doubler.
Yes.
And then it sort of changes the whole concept of closure.
So now, are we closing over anything?
That I'm not
I
sure.
don't think so. I think the number is passed to that function doubler. Then now the closed over can just access it, from the parent function. So I don't think you're using closures right now.
Okay. Anybody else with another opinion? Still getting 6. So 3 is being passed in as number here, right? So it's being passed down, and the number is also being passed because it's in the parent scope. We can still have access to it. The thing to remember is, unaona, if you remember that model the call stack, because we still do have closure kwa sababu, you see this doubler has already been called, like functionality yake ishaisha. We've already called it, right? We've already called it. And yet, if you now call double, hit a double still has access to this thing here that was already used. Like bado inajua that we passed in a 3 here. So it's still closing over this, the scope that was there before. So bado iko na access. That's why it's working. Otherwise ingekuwa ina work because we've already used this function here. Tushai call hapa. And yet when you use double sasa again, you still get a value. So it's still closing over it. So anytime unaona you've already executed a function, it's already been executed, right? And yet you still have access to values that were used during the execution of that function. So we do still have access to the 3 that was passed, and we still have access to the variable that was declared in the scope of the doubler function. So we are still closing over, we still have closure. But very good observation, Mambo. Like, we just changed the implementation, but also, Kathleen, very good question. I know what you are trying to say. I think this is what you are trying to get us to do, like to pass in like number as part of the doubler, not the child, like a parameter in the doubler. So if we now change this value to 4, what will we get? This one here, change it to 4. What is going to be the output?
16, 8. 8.
8. What if we change this value here to 10, still remain with 4? So if we change this to 10 instead of 2, but that obviously will change the functionality because the aim of the function is to double whatever number you're given to make a doubler. So if you give it any number, that's why the num is a static value. Ibadiliki. We set it and we're not changing it. If you wanted to have a triple function, let's try that. If I want to have a function that triples any number it gets, I'll write the initial. Okay, now who can direct me? How do we go about it?
You first give a number 3, that's triple. Number 3, yeah. Initial.
Then?
And then we have a function, we return a function that we pass number as a parameter. The word number. Yeah.
Yeah, hapa juu ama hapa kwa hii ndani?
Yeah, line 54.
Okay.
Then we can return number times num.
Okay, and then how do we use it now?
So first you initiate it. I don't know what you call that thing. Tripler. Yeah, like that. Yeah. Now we can have another one that.
What is the value of? Go on. What is the value of triple? What is this? Yeah. What type of value is this?
No.
What value is triple? Is it a Boolean value?
No, triple. Yeah, no, it's a function.
Good, it's a function.
Like, yeah, because it's like it's the one now the tripler. It's a function. And now we can have like triple 3 so that you can get you can triple 3.
Is it like, so the closing bit is coming from the fact that the parent function has already been executed, and yet we still have access to num, and yet num was declared in the tripler. So we are not declaring num in our inner function, like haiko hapa ndani. It's not here. So long after our tripler function has been executed, we still have access to num because it closed over it. What it did, right? So iliweka kwa a heap of memory. Now, when you want to use it now, it just goes and fetches that value kutoka hapo. That's why we have access to it long after our main function was already executed. Because you remember with the initial examples, what we were doing is, naona hapa, what were we doing here? If you compare what we are doing right now with our initial implementation, unaona hapa, we are not calling parent matryoshka and then going to our next line and then calling a different function. We are not doing that. We are simply stacking the call stack. So we are first of all calling the parent matryoshka, which in turn calls the child matryoshka, which in turn calls the grandchild matryoshka, which in turn calls the great grandchild. That's why we have multiple parentheses kama zimefuatana. Right? But now, for this one, we are actually executing the parent function and then calling the child function and asking for values that were declared in the parent function. So actually, example ulifanya hapa juu, we can actually rewrite it to use closures. If you have that mental image now in your head, because here you can see we have multiple parentheses because we still need access to the initial parent because the parent is what we're going to use to call the rest of the functions. That's why zinafuatana hivyo. But here we are not doing that. We are executing the parent function, inamalizana nayo, and then we use whatever came back as a function, right, and pass it in a number and use the 3 that we declared hapa juu. For example, these 3 that we declared within this scope, the tripler, we are using it to triple any value that we have here. If you have 10, you get 30. Okay, ni huku juu ndio nimesahau kunini. We comment this out again, we have 30. I hope it's making a bit of sense. Anyone with a question? Anyone with a question? Okay, this ability of returning functions from other functions, it's because functions in JavaScript are what are called first-class citizens. What that means is they share the same privileges as primitive values. Primitive values like numbers or strings. Think about a number. You can pass it in as a value to a function. You can assign it to a variable. You can return it from a function. You can literally do anything with it. That is the same thing with functions in JavaScript. You can pass them into other functions. You can return them as values. You can literally do anything. You can assign them to variables. So they're first-class citizens, right? And then even before we get into like higher order functions, so a higher order function, before we get to that point, Albert will talk about it, I think, tomorrow. But just a brief overview is, who can try to define what a higher order function is or isn't? Who can try to...
Hey, maybe I can try. Yeah, so it's a function that takes another function as an argument or returns another function.
Yes. Yes. That's exactly what higher order functions are. So other functions are called first order functions. Your normal functions are called first order functions. Now, React is very functional. I want us to try and look at like a very basic thing of how React does what it does. So for example, let's say we have React deals with components and their functions, functional components. I think especially from React, I think 18. So the way you normally write your logic for React is you have a function, right? You call it like, let's say header, a header component. Then you return your JSX huku ndani. You normally return something, yeah. And then now that header is consumed by another function. Then you have a function, let's say, is a keyword. And then now this main, so you can think about this as your app. You can actually call it app. And then app consumes header components. So you pass down this is what React does. It's just functions consuming functions. That's essentially what it is. So based off of what we've done today, like it should make sense because functions in JavaScript are first-class citizens. You can return them as other from other functions. You can pass them in as values, right? And you can assign them to variables. So understanding FP is very important for understanding React because that is essentially what it does. When you talk about components, they're still trying to, like, one key feature of functional programming is immutability. You're not supposed to mutate stuff. And things like state, it's React's attempt of removing like that functionality for mutating something. Inajaribu kuitoa from, because we have two types of components. We have stateful components and we have stateless components. A stateless component does not have state. A stateful component has some logic ndani yake, but again, they're just functions. So when you're normally declaring like use state, tunasemaga kitu kama you have your const, then you have your this, and then you're destructuring the use state, which in of itself is also a function. So use state is a function that returns what? First of all, it returns the value, and it also returns a function, the setter, the one that is going to set your values. So you can think of it like this. It's returning an array that has your state set to something and a setter that is set to function as something. So when you're thinking about React, just think about functions and you'll find hautapotea sana. You'll start to understand why it's doing some of the things it's doing. Any question about functions? I hope that makes it a bit easier to even think about React.
Question: How is scope chain used in React?
I'm actually not sure. I'd have to do some research. I'm not sure how they use it, but I'm pretty sure they use it somewhere. Does anyone have an answer for that? Guru React. I think we can do some research, then see how it does it, because I'm pretty sure it does utilize the scope chain.
Okay.
Yeah, I'll do some research and then I'll get back to you. But like, is it making sense? Like what we just did? Is it making sense even when you get into React? Why it's behaving the way it's behaving? Why you always have functions everywhere? Your hooks, all of them are functions. Sorted. They just return like different stuff. Your use reducers, your use memo, your use effect. Some of them take in 2 things, some of them take in more than 2, some of them take in 1 thing. Because like even your use effect is just a function that takes in another function first. And then it also takes in a dependency array. So an array. Something that you're going to use to tell your use effect when to re-render again. Otherwise, it's going to re-render every other time. The basics should make sense. By the time we are getting done with FP, when we get into React, it should make a lot of sense. Any questions? Anything we have not touched on, or anything we can touch on tomorrow? So tomorrow
I have a question. So, yeah, so like I was asking, essentially when you call a function inside another one, yeah, you're trying to access its return value. That's essentially it.
Yes.
Okay. Because it used to give me some kind of headache calling functions inside functions. Like I thought it's something like that. Maybe you're trying to access its return value.
It can get confusing to think about it, but like once you understand, I want you to think about functions in JavaScript like you think about a string value, like you think about a number value, like you think about a Boolean value. They have the same privileges. Unaona vile unaweza andika function yenye ina consume like an array of things or is consuming a string value. Same thing with functions. For example, the high order functions, built-in high order functions, come a map, right? Map takes in a function. So for example, before we end, let's just do map. So map basically takes your array. The way to remember easy functions, like what they do and what they return, is for each doesn't return anything, just iterates over your array. Map does something. It can transform your initial array into something else, but the length is the same. If you have an array that has 10 elements, right, and you use map, you're also going to get 10 elements back. And the reason, by the way, the reason why higher order functions always return new values, right? When you use map, you're not returning the same old array, are you? You're creating a new array that is now used. That is because one of the key elements of functional programming is immutability. That's why those higher order functions don't mutate your original array. They create new arrays because immutability is very big in functional programming. So if you have like an array of 1, 2, 3, 4, right? For example, you have a nums array. Now, I want to use map, loop over this array, and return a new array with the elements doubled. That is what I want to do. So the thing to remember with map, it's going to return an array of the same length. It does not edit your length. Kama uliweka array iko na 5 elements, itarudisha array iko na 5 elements, albeit another array, but the length is the same. That's a key difference to remember when you're using map. Reduce returns one thing. Reduce does not return the same length, right? Sort returns the same length, right? What's the other? Filter does not return the same length because you're filtering down the array. So now, how do we implement, if there's someone who is familiar with, let's just do a teaser of higher order functions. I want to write I want to have an array, right? I want to loop over these ones and return their values doubled. Can anyone direct me on how to do that? I want double array. Anyone an idea of how we can do that? Just do one, and then like tomorrow, Albert can walk us through the rest. Anyone?
You can use the map. I was trying to talk and I got choked.
How do we do it?
So let's use map because as you've mentioned, map will return a new array with the same length, meaning that it will contain all the all the items in the previous array, but now manipulated. So map will loop through the whole array, manipulating each item. So let's do nums array and then dot map, and then since you said map is an higher order function, it will take in a function. So let's even use an arrow function. So we can pass an argument. So this argument will represent each item in the array. So we can call it number. So each number in the array, and then we can do something with that number. For this case, we want to double that number. So we'll do number times 2. And this now will return an array of similar length with all items doubled or multiplied by 2.
We have 2, 4, 6, 8. Okay, I want to throw a spanner in the works, Albert. Now, what if I want this functionality to be its own function? So I don't want to pass it inline. How do I do that? I don't want to pass it inline here. I want it to have it as a separate function. For example, a function called like multiply or something. Because here we are passing it inline, we're just declaring it here. How do we remove this functionality? And instead of passing the function here, like the way we are doing declaring it here, we want to declare it somewhere else and then call it up for your map.
So take whatever you've highlighted and let's create a new function. What do you want us to call the function? Maybe
call it multiply.
Use the same syntax, use the same arrow function. So assign it, use the assignment operator, and then paste in the code that we had earlier on. And then now call that method, the multiply method. Wait, I hope this will work. I needed to test it, and with a number, not with a number now. Actually, don't call it directly. This map will still need that function, so you still need to give the callback. So write an anonymous function that takes in nothing. Just remove that multiply kwanza. Write in the anonymous function. And then return that function now. Return the multiply, and then pass in an argument, the number, and that number will also be passed as a parameter to this multiply.
Where are we getting the number from? Are we passing it in here now?
Yeah. We're passing it there. And then also supply it to that.
So we invoke multiply here.
Yeah, we invoke multiply with that number again. The num, yeah.
So it has worked, but there was an easier way. You would actually really figure it out.
Oh.
If you remove this and you just pass in multiply.
Oh, it's already a function, so it's like you're passing a function. Okay.
Yes.
Okay.
It already works.
I think
I was
overthinking.
Yeah. Because this is what we mean when we say like functions are first class citizens. We just have a number. Yeah, we can pass it there. So you can see.
Okay.
Yeah.
So it is actually being brought as a function. So
yes.
Yeah.
It's invoking it for us. We don't even need to have parentheses.
Oh, sure.
Plus the number. So the number, number is simply whatever we are iterating over. We've given it already the array, so it knows that number should be the elements.
Yeah, I think what was confusing me is that the React thing where you have to put in the function. The setters.
Yeah. That's still, I think, about mystery and immutability. Anyway, any question? We have exceeded. Any question? I hope we've given some clarity today. Like a lot of stuff, but they do need like some practice. But we'll continue tomorrow. So Daniel will do like pure functions and what they are. Then Albert will do higher order functions. Then we'll also do carrying. There's something called carrying. But we have covered the grid, like what is like really important for FP. We have already scopes and closures. They're very confusing. But we'll do some challenges towards the end. We'll do some challenges just to make sure to meshika. So anyone with a question? Anybody with a query? Anyone with a question about what we've done today? Okay, so tomorrow Daniel will finish up his section and Albert as well. Alafu sasa after that we'll just do some challenges just to make sure to meshika. And then now we'll take like a mini break where we'll do projects. And then to Manzana projects, we jump into React. So you guys enjoy the rest of your evening. I hope you enjoyed the session, and I will see you guys tomorrow at the same time. Bye.